we know what is specific heat capacity in case of solids. We have studied that earlier, and it is denoted by the symbol small c, the specific heat capacity in case of solids. The definition is this: the amount of heat required to raise the temperature of 1 gram of substance through 1 degree Celsius. So this is what is specific heat capacity in case of solids, and it is denoted by symbol C, and its equation is Q upon M delta T. Amount of heat required to raise the temperature of 1 gram of substance through 1 degree Celsius or 1 degree Kelvin, and the unit is joule per kg per Kelvin or calorie per gram per degree Celsius. These are some of the units that we use. Now, in case of gases, the situation changes slightly, and let us see what are the change in the situation. In case of gases, again, the equation or the definition is of course the same. C is equal to Q upon M delta T, the amount of heat required to raise the temperature of 1 gram of gas through 1 degree Celsius. But we have a challenge over here. And if I use this equation, if I take a situation like this, let us say we have a cylinder and we have a piston over here, and we have some gas at some temperature PVT situation. Now, the difference is, in case of solids, we can increase the temperature. We can increase the temperature, or we can change the temperature by compression or expansion. So you need not necessarily give it heat to increase its temperature or change its temperature. So supposing I compress this gas, the temperature changes. So let us assume a situation where I am compressing this gas, and therefore the temperature changes. So the equation, this equation, if I use this equation to find out specific heat capacity, what will happen is C will become equal to, the amount of heat given is 0, and that is what changes the entire dynamics. Q is 0 because you're not giving it heat, you're just compressing the gas and temperature is changing. So this would be 0 M delta T, and therefore C would be equal to 0. And we very well know that that's not possible. Okay, this is situation number 1. There is another situation also possible theoretically, wherein we can show that the specific heat capacity of a gas is infinity. How? So again, I take the same situation. Let us say we have the same piston cylinder element, and let us say we had compressed this gas over here. Earlier the piston was over here, we have compressed it and the piston has come over here. The temperature has changed. Now let us say I expand this gas, meaning that we apply force such that this piston moves out. So we apply force on the piston moves out. The gas will expand. When gas expands, its temperature decreases. Temperature will start going down. And let us assume that we continuously keep on giving a small quantity of heat to this such that the temperature remains constant. Let me repeat this. Because we are pulling the piston out, expansion happens, temperature decreases. But at the same time, we are also giving in some amount of heat to this system such that the temperature is made to remain constant. So if I use this equation, C is equal to Q M delta T in this case. Q has some value because we are giving Q heat to the system, Q M. Delta T will be equal to 0 because there is no change in temperature. So this will become equal to 0, and you will have specific heat capacity as infinity. So now we very well know that this is not possible. A gas cannot have infinite specific heat capacity. So based on these situations, we conclude that the specific heat capacity of a gas has a relationship with the pressure and volume of the gas, so the pressure and volume situation of the gas. And therefore, we will have two different specific heat capacities of gas. We denote them by small Cp and small Cv. This is specific heat capacity of gas at constant pressure. This is specific heat capacity of gas at constant pressure. So we are not changing the pressure, and we're seeing how the temperature changes, and based on that we have specific capacity. Cv is specific heat capacity of gas at constant volume. We keep the volume constant and see how much amount of heat is required. And the definition is very similar to what we had discussed earlier for solids. So let me put it up over here. This is Cp, the specific heat capacity at constant pressure amount of heat required to heat 1 gram of gas through 1 degree Celsius at constant pressure. This is very important. Similarly, for CV, we will have this definition. This definition, CV, specific heat capacity at constant volume. Again, the same definition. The only thing that changes it at constant volume. Amount of heat required to heat 1 gram of gas through 1 degree Celsius at constant volume. So this is CP and CV, and they're denoted by small cp and small cv. Now, instead of 1 gram of gas, let us say we have 1 mole of gas. 1 mole of gas. In that case, if we take 1 mole of gas, in that case, we have the specific heat capacity is known as molar specific heat at constant pressure and molar specific heat and constant volume. And the definitions would be something like this. Molar specific heat is again nothing but same, right? Lies over here, specific heat capacity at constant volume, but instead of 1 gram, here we have 1 mole of gas at constant volume. And the relationship is this. This molar specific heat will be denoted by capital Cp. So capital Cp, so this should be Cv. Cv, capital Cv. Capital Cv is m into Cv, where m is the molecular weight. So if I multiply molecular weight with Cv, small cv, then I'll get capital Cv. So molar specific heat, or I can write it in words over here, molar specific heat capacity is equal to molecular weight into specific heat capacity. Similar definition we will have for molar specific heat at constant pressure. Same, only the change is that we're using 1 mole of gas. So, in case of gases, we have 2 specific heats, one at constant volume and one at constant pressure. And the reason is because in gases, it's possible to increase the temperature. In fact, I should use the word change the temperature by compression or expansion. That is, without giving heat. Whereas that is not possible in case of solids. Solids, you cannot change the temperature by compressing them or trying to expand them. Whereas in gases, that is possible, and therefore they have 2 different specific heat capacities, one at constant pressure and one at constant volume. In the next video on specific heat capacity of gases, we will discuss how Cp and Cv are related to each other, which one of them is larger, and we will also look at the relationship between Cp and Cv, which is known as Mayer's relation. Thank you.